Hey, there we go. Thought I should check my audio before I do anything. Turns out it was off. How's everybody doing? Hey, hey. Okay. So let me know if audio is weird. I'm going to be starting a brand new game project. I was working on stream on something called Space Bump. But I realized as I was working on that I was pulling from a big library of code that we have built up over a long time. And so if somebody else wanted to follow along with what I was making, they might have a hard time because, of course, they don't have a library of like 500 scripts laying around that they can just use. So I thought it would probably be more helpful for everybody watching if I started a brand new game project from scratch with nothing in it. And then we can kind of work on this stuff together, so that you guys can see how everything is built. And then also I'm making the code available in a GitHub repository. So that anybody who wants to can just pull the code down and play around with it. You could even use it in your own projects or whatever. I don't care. The only purpose of this is just for teaching and showing how things work. So we're just going to go ahead and get started with this. I'm trying some more chill music though. There we go. There we go. Okay, so we are in a blank game maker project. This is just called Stream Game, and this is a programming GML game maker project, not a drag and drop project. So all we have in here is just a room, and that's it, and that's what's there at the default. You can see it's this little guy here. So first thing I'm going to do is just double check in the main options that my game is at 60 frames per second. Everything looks good. Platform settings, we're going to set this to version 0.0.1 because we're in alpha, and we're going to call this Stream Game for now. Okay, this is by Seth. It's called Stream Game. Description, Stream Game. Obviously, 2019 here. Okay. And then we're also going to go to the graphics and just double check that things are looking the way we want, which is we want to check this interpolate colors between pixels. Because if we don't do that, then things get kind of crunchy. In 3D games, this would be referred to as anti-aliasing. You may have seen that in graphics settings options. It basically like rounds colors between pixels. Okay, sure, we can display the cursor for now. Let's just do a borderless window. Actually, no, let's go. Okay, and the texture page size, we'll go big, because we're going to make this game in HD. Maybe, I don't know. Okay, that's all we need to do for now. Just a couple of little maintenance things. So what I'd like to do for today, this is going to be a couple hour stream. So what I'd like to do is basically get some initial rooms set up and get the general project structure built, and then try to get some kind of like character in the world walking around. So I might move a little bit fast at sometimes, but this will all be available on YouTube later, so you can always just slow things down or pause or go back, and you can always ask questions in the chat as well. So first thing we're going to do, pop open room 0. We don't need this background here, so I'm just going to turn that off. We're going to rename room 0 rm_init. This is going to be our initializer room, where we start the game here, and then we initialize everything we need to do, and then we move into the rest of the game project. All right, so let's go to our room settings down here. So this room is tiny, 1024 by 768. I always like to just make my rooms 10,000 by 10,000. I had never actually used the room editor for anything. I just use my rooms as a place to drop an object, and then I make the object do stuff with code. So I won't really come back to this pretty much ever, but it needs to be set up at least once. Okay, we're going to enable viewports, clear the viewport background. Viewport 0 is visible, so we have the ability to see stuff. And for now, I'm just going to force the viewport to be 1920 by 1080, which is HD. Later on, we are going to probably write a script that dynamically changes the resolution of stuff as we go. But at the beginning, we can just hard code that because, you know, who cares? All right, I'm not doing anything else. Okay, so we got our camera set up. That's all good. All right. Now we're going to make an initializer object. O underscore init. A lot of people use obj underscore. I don't know why. It's longer. I'll just use O underscore, you know. In the create event of our initializer, we're not going to really do anything right now except room go to, and we're going to go to our main menu room, which doesn't exist yet, so we will duplicate this, duplicate our room init, and we'll call it room main menu. Now it's important to have a main menu because without a main menu, it's not a game. So always remember that. And we'll make a underscore main menu, and we will also just go ahead and make a gameplay controller. And we'll make a gameplay room. We're just kind of building out the structure here of the game. So at base, all of our games just have a main menu and a gameplay room, and that's really all you need to kind of get things up and running. All right, and then our initializer room, we will go back to our resources. We're gonna take our initializer object, drop it in there, kill that, main menu room, main menu object, drop that, and gameplay room, gameplay controller, drop that in there. Okay. Now, if everything works according to plan, we will never have to go into the room editor again. So, we did it. All right. So our initializer object is going to just take us to the main menu room. A lot of times people like to use room go to next or go to previous. I never use these because these are based on the order of your rooms in the project. So if you ever need to reorder things for just organization, you'll end up in a scenario where these functions actually take you to a different place. So I just act like those functions don't even exist. So we're going to go from the initializer room to the main menu room. And then the main menu object is not going to have anything going on yet, so we can start with this. All right. So first, we are going to want to draw some text on the main menu to say, you know, the title of our game. So the first thing we would do is we can just run this draw text ext transformed color. The question is, where are we going to draw this? So this is in the GUI event, and so the camera has nothing to do. Do we always start with the main menu? Not necessarily, but I feel like it's good to have one, you know? Because, you know, it feels like a complete game, even if it's garbage. All right, so the first thing we're going to do here is we need to draw some text, but we're also missing a font. So let's create a font here. I'm going to go ahead and use a font that most people probably have on their machines so that we don't have to worry too much about, you know, people not being able to pull this down. Let's just go with 48, and we'll call this FNT header. Actually, let's go even bigger. I mean, this is HD, right? So title for the game for now is going to be Stream Game. Okay, so normally what you would do here is you would say draw set font FNT header. And if you draw your text using this draw text ext blah blah blah, First off, we need to figure out where to draw it. This is on the GUI layer, which means that basically top left corner of the screen is always 0, and the right side is always going to be the size of the display, so 1920 in this case. So we'll just do that. There's display get GUI width and display get GUI height. And we're going to draw this halfway across the interface, and we'll actually draw this down from the top. So we'll say, maybe draw it like 200 pixels down or something. So we won't worry about this. Text Y draw. We're going to call this, what are we going to call this? Stream game. And now we have all this stuff. We don't need ext. We just need, yeah. All right. Scale 1, 1, 0. We're going to draw this using some flashy colors. The brightest color of them all. White. Okay. And now we can go ahead and just run this and kind of see what happens. F5 is a nice shortcut to boot up the game. All right, so you're going to notice here, this text is drawing in the middle, but it's left justified. So here's something you'll often see, is we need to align our text vertically and horizontally. So you'll oftentimes see people doing this kind of a thing, where anytime they need to put text on the screen, they're going to call these three functions. So we're going to make our first convenience function here. And we're going to make a text drawing thing. And we're going to say font set. Take these, put them in here. Because I don't have to redo these three function calls every time I make some text, right? So font, and then we're going to have H align and V align. Argument 0. Let's just do, I'll try to make this a little more readable. Font. And the vertical alignment. Okay, so now we can take these three functions and bake them down to one line of code. So we'll say font set, that, and that. Okay. Later on, since we're always setting our fonts using this font set function, later on we can add some features to that script, which includes things like setting a global font spacing and stuff like that. Okay, so that's first thing. Let's rerun that. Make sure that's doing good. A stream game. And we're going to want this text to kind of wildly whip around the screen to create a sense of excitement and enthusiasm. So sine waves are great for this. So I'm going to go ahead and use some game seconds equals. So get timer is just how many microseconds have passed since the game was launched. And a microsecond is a millionth of a second. So if I want how many seconds the game has been running, then I'll just do this. And then I can go ahead and update the position of text X draw and Y draw by adding some sine waves to them. So for starters, I could just do, sine game seconds, maybe like times 5. So a sine function generates a number between -1 and 1, and it's a nice wave like this. And so if we want that wave to move faster, then we multiply the time inside. And if we want the wave to be bigger, then we multiply the whole thing outside of the function. So I can just go Y draw. So I'm going to do this wrong on purpose, and then I'll kind of show you how to tweak it. So what this is going to do is it's going to apply a sine wave to both of these, but they're going to be totally synchronized. So that's going to mean it's not going to, right? So they're both moving in the same way. X and Y are moving the same. So that's not really what we want. So instead, we can do something simple like just pick a random number that is some other amount and then multiply one axis by that amount and another axis by the other amount. So now we have two separate timers running, and that's going to give us different outcomes. Oh my god. And then we can go ahead and also do that to the rotation. Text rotation. So we can rotate it by 10 degrees. We'll just pick another amount. Since the text is really long, then rotation is gonna you're gonna really feel it. So even 10 degrees is probably gonna be plenty. I need to actually use this rotation though. Angle. We got ourselves a game. So this is only 10 degrees, but you know, that's a lot. And if we really want to sort of beef it up, we could even just go ahead and, you know, multiply the base timer by some other number, and that then cascades out across. So now we've got, you know, we got this, which I feel like, you know, really conveys a certain something about what's coming. Maybe we'll slow that down a little bit. Okay, so we have our stream game. And then if we want to, we could maybe even like do this again and do something real dumb like, okay. Foreground. All right, so game seconds plus equals 1. Okay, so we'll add 1 to the timer and then recalculate everything and draw everything again. I'm basically just messing around right now, just to see if I can do something fun with the title. What? That's a little too much. So we want to just offset the game seconds a little bit. No, that's not enough now. Okay, now we've got some kind of a weird thing here. And I want to make some good colors. So let's get Inkscape going. And we're also going to want to draw a background color, probably. So we'll do that in the draw event. All of our buttons that we put on the main menu will be in the draw GUI event. So those will be drawn on top of the draw event. So the draw event will be in the back. All right, let's open up Inkscape. Let's figure out some colors here. So we could probably make a color palette that we can then just use throughout the game for the most part. And then we can adjust that color palette over time. So this is way too blue. We're going to want something a little more calm. Okay, that's a pretty nice blue. Anything that's 0, 0, something else, never do that in your game. So never do these colors. And especially never put them next to each other. I mean, look at this. This is terrible. So let's get some nice colors in here. And then we can take the RGB values of these and then initialize them. Okay, so we got kind of like a nice light green. We've got... So the idea here is we'll establish some kind of a baseline color palette, and then we can use that throughout our interface elements and stuff. Some kind of red. So still pretty bright, but not quite as blinding as what we had. All right, I'm going to slap this over here. And we are going to go to the RGBs. And this is where our initializer comes in. So we can probably just make these out as macros. So let's go C, we'll call it soft blue. Make color RGB, 32, 105, 255. And we'll say soft yellow, soft red, and soft green. So this is using the convention that GameMaker has, where with colors they'll say like sea aqua or whatever. So this way, whenever I'm pulling up colors, then my color macros will also be included alongside all these constants here. So, all right, so we have this soft yellow, 255, 200, 0. Soft red is 255. And if these turn out to be too bright, then we can always adjust these macros. But by keeping them in one place, initialized here, then it's really easy to adjust the UI color palette of the whole game later. Soft green is 167, 255, 0. Okay, so now for this menu, we can take our... So now that we got that, we're done with that. We can maybe do this yellow here, and maybe soft blue in the back. It'd be cool to see the movement code in Space Bump. Yeah. We might have something similar. Alright, so we have this, what some would call a dope-ass title. And they'd be right. And let's go ahead and make a background just so that it's not pure black back there. And we'll just do that by drawing a rectangle. So this is going to be... This is using the draw event. And this is just going to be drawing a full screen color. So I'm going to actually make a script to do this because it's something we're probably going to want to do a lot of. So draw full screen color. Camera get view X. And you'll see why I'm going to turn this into a function. Actually, let's do some... Let's get some camera functions in here, too. You notice, if anytime I want to get the left side of the screen, I have to do this, this is going to get real bothersome. It used to be the case that there were simple variables called view X view and view Y view. Get timer, the values would grow forever. They do. But that's okay. How would you generate a black outline? You would need to use a shader for a black outline. But I'm pretty inexperienced with shaders, so I'm not gonna dip my toe into that. Draw full screen color, view X view. There. And we'll just get view Y. We'll make some more of these. View right. Okay. So you notice that anytime I see something happen where I think, wow, this is going to be annoying if I have to do this a lot later, that's an opportunity to create some kind of convenience function. So now we have view X view, view right, view Y view, view bottom. And then let's also do view center X, which is actually, so it's halfway across the width. View center Y, which is halfway down. All right, so now we got a bunch of functions that we can more easily use to manage views and cameras and stuff. And we're gonna make this draw full screen color script where we just give it a color. Okay, so now we're gonna say draw rectangle color. We'll just give ourselves a little bit of leeway here. Okay, so this should just, now we have a single function to just cover the whole screen with a color. And let's also give it an alpha. Zivix, welcome. Oops. So when you run draw set alpha, then any rectangular shapes that you draw using Gamicus draw functions will automatically take that alpha. We can also make these optional arguments by doing this. Oops. All right, so what we've done here is we've said if we use these little brackets instead of saying argument 0 like that, then it turns our arguments into an array, and we can now iterate over that array, and we can have optional arguments and stuff like that. So now we can sort of overload this function. So by default, if all we did was say, draw full screen color black or something, then that would just cover the screen in black and it's done. But if I wanted to now make it more transparent, I could add an alpha argument, and if I wanted to make it, transition, then I could do that as well. So now we have our draw full screen color function. In the main menu, we're going to draw full screen color, and let's make a let's also make a convenience macro here. Let's see. I think you can do this. We'll find out. BG color equals, actually we can do this in the initializer. I don't know if you can actually use macros this way. I've never tried it. So somebody let me know if you can't. Otherwise, I'll just make it into a function, which is also fine. RGB. All right, so we want this to be kind of like a nice deep, I don't know, purple or something. So we need some red. So it's like 50. Not really any green. And maybe a little more blue. Maybe something like that. See if we get a compile error from that macro thing. Nope, that worked. Maybe a little darker. And we could even darken it toward the bottom. Zivix, things are going pretty good this morning. Okay, so we're just working on this main menu. Feeling pretty good about this. So I'm going to commit this, and this is going... let's see. Set up main menu and drawing of the main menu title. Okay. So this means I have a link to the GitHub. I'll put that in the YouTube video as well, but also on, if you scroll down on the Twitch page, there is a link to the Git repository. You can download this project as a zip, or you can pull it down using Git. So all this stuff that I've done, you can just have it. You can just take it and do whatever you want with it. Okay, so we have our main menu. Next up, we need to be able to go to the gameplay screen. So we're going to need to create some kind of a button management system, but I'd kind of like to just get into the gameplay for now. So I'm just going to draw some text to the screen that says, you know, like press space to start or something, and we'll just do it that way. Font reg, which is going to be our regular font. Arial, let's see, what do we want? What do we want? Bahnschrift. I don't know if this is a normally available font, but we'll see. So this is going to be just our regular text that we draw. 36 might be kind of big, but we'll find out. So on the main menu, draw GUI. We're going to do this again. Font set, font header. I'm also going to make a convenience function out of this. As soon as the draw text transformed color requires an X scale and a Y scale. And it also requires 4 color arguments. This is pretty annoying because most of the time you're not going to want to squish your text on one axis but not the other. And most of the time you're going to want to draw it as one color. So I usually make a simple function. It's just called draw text, which does this. And we're going to do this with optional arguments. X draw, Y draw. We need string, scale, rotation, color, and alpha. So what we're going to do is we're going to front load this function with stuff that we generally need all the time, which is going to be scale, color, et cetera. And usually text is drawn at an alpha of 1 and non-rotated. So we can leave those arguments for last. That way we don't have to worry so much about including them all the time. So rotation to 0. And alpha is 1. If we have more than 6 arguments, then the alpha will be argument 6. Okay. So now we can also turn this into helper functions here. Get rid of that. X, Y, string, scale, and color, And then I always put little square brackets for optional arguments, as well as what their defaults are, so that I have a good reference. So now I know here that in my helper text, I know that I need to provide these first 5 arguments, and then I can override these last 2 if I need to. We have extra ydraw string, scale, scale, rotation, alpha, color, 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 color. Any particular reason why I changed the default font colors? Yes. Yeah, they're actually... GameMaker Studio 2 has a huge diversity of what is available for color coding. So like it can tell the difference between different types of variables and like resources versus functions, etc., etc. But the default color scheme doesn't actually differentiate between those things. Let's get some more chill music on here. Yeah, so their default color scheme doesn't differentiate between many things when it could. So I just overwrote it just to make it more obvious what's happening. Okay, so now we have our draw text function, and now we have this super long thing, and I'm going to redo this just so you can kind of see. Scale 1, color is that. It's alpha 1. So now we've got this instead of all of this. And you'll also notice that we are duplicating this title here. So I'm going to initialize that in a variable. Game title. So that we don't have to redo it. So now we just change it here in the create event. Okay, now we are going to write in the middle of the screen, draw text. And you may also notice I've got this display get GUI width times 0.5. This is just like my camera stuff, so I'm going to go ahead and make some convenience functions for that as well. GUI center X. Right. So I'm making these into functions because I'm probably going to maybe do some stuff with this later. And GUI left and top is always 0. So that's... Oh, they updated the text colors recently? Nice. That's good. Okay. So what are we drawing here? We're going to draw some helper text that says like, hey, push spacebar to do stuff. So, GUI center X. We'll say, oh yeah, let's do this too. So this is mostly just for my own personal, saving myself some typing for now. GUI height, GUI width, instead of display get GUI width. We'll draw this 2/3 of the way down the screen. We're going to press space to tango. We'll draw this at a scale of 1. This is going to be... Let's make this white. It's definitely possible to overdo it with wacky colors. Ooh, messed up my colors. soft yellow. And we also should go ahead and make this pulse a little bit. So our scale, our helper text scale is going to be, let's see, 0.9 times timer. We're going to do a sine of this. So this is just the same thing that we did up here, just a little bit sloppier. And what this means is it's starting at a base scale of 0.9. And since sine goes up to 1 and down to -1, then this is going to take us up to 100% and then down to 80%. So it's going to kind of zoom in and out. Press space to tango. Okay. And just to kind of make this more in line with what's happening on the title, we should probably make this go a lot faster. Are these scripts we have in the bscotch pack? Some of these things are not scripts in the bscotch pack. They come from other functions. Yes, I feel like this conveys the idea. This is what we want people to feel. Generally overwhelmed and anxious is a good starting place for like getting somebody into your game. Okay. Now in the step event of the main menu, we will listen for the spacebar. So if you press VK's, I think stands for virtual key, which is just like the key code for the spacebar button. We're going to go to the gameplay room. Let's see if this works. All right, we're in. We're playing the game now. Did I decide what this game will be? No. I'm going to start with just having a character running around in sort of a top-down view, sort of Crashlands perspective. And then we'll just kind of go from there. I think it's kind of a nice mix. That style of game is a nice mix between not having too many physics issues to worry about. It's like if you're making a platformer, it's all physics, and that's very tedious to program and not very interesting to watch programming of. And something like Space Bump that I was working on, or something more like a strategy game or a really heavy numbers-based RPG, is also just a lot of like stats management and stuff. So ideally, we got something kind of in the middle, almost like a Quadrupus Rampage kind of a game where it's got a lot of action that's then supplemented by various stats and loops and stuff. So we'll kind of just feel it out, and I'm happy to take suggestions from the chat as well about what kinds of stuff you guys want to see in the game. Okay, so we can now press space to get in there, so I'm going to go ahead and commit this. Added helper text to the main menu, and you can press space to go to the gameplay room. Oops. All right. So we now have our gameplay controller. I'm going to make a gameplay folder in my objects, and the first thing we're going to do is we're going to make an object called world element, and this is going to be the parent object of every single thing that exists in the game world, because it's generally going to be the case that there's going to be a lot of shared variables and attributes, like maybe everything is going to have a width or height. Maybe everything is going to have a variable to determine whether we should draw a shadow or something like that. So we're just going to bring everything under one umbrella, and we're going to have this world element. And we're going to also have let's see, we'll call it a world background. So this background is going to just do our full screen color. And once again, I'm going to open up Inkscape, and we're going to come up with some kind of a baseline sort of like terrain color. And we're gonna do this with a gradient because it's always better. Let's bring that alpha up. So we're gonna just decide, as we're walking around the world, before we put any tiles or anything else in, we want there to be something, like some kind of color. So let's just figure out what that's going to be. We want it to be lighter toward the camera. It's 55, 255. So we kind of go in here. Maybe it's a little too green, so we can pull the saturation down a little bit. So we'll just do something like this for now. And this will be, quote, grass. Okay, let's see. So we're going to draw this at 76, 113, 4. Alpha 1. Bottom color is 108, 146, 11. Okay, and in our gameplay controller, we are now going to spawn the world background. Now, GameMaker has either instance create depth or instance create layer. I'm going to do instance create depth. With a top-down game, you're actually moving the depths of things a lot, and so layers don't work quite as well for that. So we're going to make this at 0, 0, 0. World background. Oops. Depth 0. So with the way that I do a lot of my code, I actually rarely care like what depth things spawn at and all that. So this is going to also be one of those things where I have to type a bunch of extra stuff for no reason for my most common case. So we're going to make another convenience function, instances. Instance create. Oops, object ID. And we're going to then allow you to optionally say where it spawns, and we honestly don't care what the depth is. Let the object figure that out on its own. Equals 0. Same thing. Spawn it here, spawn it there. Pass in the object. There we go. So now we have a much more convenient function. So instead of the above, we'll just say there. Much better. So that's all we're going to do in our gameplay controller. And let's just verify that this is doing what we want. Okay, we've got our green world. All right. Next up, we'll make a player character. The parent of the player is going to be the world element object. just so that we have those shared variables. And in our world element, we're going to initialize with just some arbitrary numbers here. But we want everything in the world to have a width and a height, and we have to decide whether things will draw a shadow, which we'll deal with in a little bit. All right, now we don't have any visuals for the player. So I'm gonna make some using, just gonna make some really simple placeholder art for this. So we'll start with, so right now we're at 70 by 70, which maybe is good, I don't know. We'll just make one and see. So we're just gonna make a white player character with a black outline and some eyeballs. Okay, and the most important thing about any characters in your game, anything with eyes has to blink. That's the rule. Otherwise, it's fish. I don't know. So we're just gonna make a second sprite with eyes closed, and we'll deal with that as the time comes. Player, this. All right, so we know that this sprite is 70 by 70, so we're going to set the player's width and height to that. We could probably come up with better ways to automate this once we get a better sense of how all this comes together. Okay. So this player, we're also going to give everything a Z and a Z speed. So when you're making a top-down game, where you're kind of looking at things down at an angle, you're actually kind of simulating 3D, because you have this flat plane that everything is walking on, and then things kind of bounce along on top of that plane. And so we're going to create this Z-axis, which is things coming up off the ground. And that's mostly just used for drawing, so that we can make things look like they're flying around. And shadows are super important for creating that effect, so we should be able to hit that during the stream. All right, so this player has a width and a height of 70. And then we're also going to need to, of course, everything in this game is going to be blinking, right? So we're going to make some blinking functions. Blinking. Sprites need to have an odd number of pixels in their widths and heights. Yeah, so that kind of depends on what you're doing. So in this case, the sprite is 70 by 70. And the origin is at 35, right? So the way that this ends up working is that there is no middle pixel, right? So the middle of the sprite doesn't go between pixels, it goes onto a pixel. So if it's 70 pixels across, then whichever pixel you choose, you're going to end up with it being offset. And you'll notice that if you have something that's spinning, you'll see that it kind of looks like it's wobbling by 1 pixel as it spins. And so in this case, we don't really care that much about this because your character isn't a wheel, and it's big enough that when we X flip it, it's not really going to matter that much. Let's see, and it's blinking. All right, so in this, we're just going to say blinking is 0. Actually, let's do this. All right, so blinking is 0, and then we have a script called blink. I know you might be looking at this and be thinking, I thought we were making a game. All we've done so far is make a main menu, and now we're having a character that blinks. But I say, if your character doesn't blink, then nobody's going to play your game anyway, so it doesn't matter what mechanics you have. Since create O player, and we're just going to make the player at center of the view, and we'll figure that out as we go. Another thing here is this world background needs to have a depth a little further back. Okay, and then in the is blinking. So what we're going to do with this blink variable is this is going to start at 0, and we're going to say if blinking is less than or equal to 0, then we're going to give it a random chance per frame. Maybe like that. We'll just put some numbers in and just see how it works. So if you're not blinking, then we're going to go ahead and just every frame give you a random chance to blink. Plus equals. So I'm using room speed for now. We're going to actually update this and get some delta time in here. But for now, we'll just do this. All right. So now we start incrementing it. So if blinking is greater than 0, then we keep incrementing this timer. And maybe if it's greater than 1, then we reset it. And the way we interpret this, so we have this script called isBlinking, where we basically ask a question about this blinking variable. Where we say, oh, it's greater than 0, and it's less than 0.15. So this means for the first 0.15 seconds after a blink begins, then we'll say, yep, we're blinking, and then the rest of that duration is just a cooldown before it resets. So, so blink. It's blinking, and then in the step event, we'll just say blink. Or we can do it in the draw event, that's also fine, since it doesn't particularly matter. And then we will say draw sprite ext, draw myself. And the image that I'm going to draw is blinking. X, Y, scale, scale. We'll worry about the rest of these arguments later. So what we should have now is a character that blinks. I think. Game of the year. All right. Next up, let's get some shadows in here so we can actually see where this character is standing. Oh yeah, let me push this out. Okay, so let's make a shadow sprite. Shadow. So shadow is really just, you know, a circle on the ground. But since we're looking at an angle, it's going to be squooshed into more of an oval shape. we'll just do that. That's pretty good. Good shadow. And then we'll just clip that. Boom. Auto trim. So now we've got our shadow. Now, I could just draw the shadow in the draw event of the player. Maybe at a lower alpha. Actually, the trailer voice is my brother. But we have a similar voice, so, you know, it makes sense. Okay, so I'm drawing this shadow behind this guy. You can't see it. It's back there, but you can't see it. He's just covering it. How well do you find GameMaker projects work with Git? Yeah, I mean, it's tough because most things you do in GameMaker affect multiple files at once. And if you're not familiar with the file structure of how the project is built, it can definitely be a bit of an issue. But so far it hasn't been too bad. We've been doing a lot more team collaboration with stuff, and it's been fun. I think any code base that you work with source control, you're gonna have a lot of conflicts and stuff as the team gets bigger. So it's just one of those things. Okay, so for starters, this is gonna sound weird. Here's what we're gonna do. So you'll notice that this character has an origin at the center, which means whenever we say draw the character like at position 0, then it's centered here. And this is so that when we rotate the character, that it rotates around its center and not around some weird position. But in the game world, we actually want to build everything around the character's feet. And so instead of drawing the character at its exact X and Y position, we're going to draw it up a little bit. So we're going to draw it up by half of its height. So instead of drawing it at Y, we'll draw it at Y minus height times 0.5. Okay, and this will also pull the character up over the shadow, and then you'll see the shadow actually represents the location where the character truly is. So this shadow is the character's position in the world, and the character is just a visual representation drawn kind of on top. Okay, so we have that. Let's get some basic movement code in here so we can kind of see how that works. So we're going to do some WASD controls. So I'm going to do something that might seem a little bit strange, but you'll see as we go why this is useful. So I'm going to make an array which has D for right, W for up, A for left, and S for down. So 0, 1, 2, 3 correspond with 90-degree increments. So 0 is 90 times 0, that's 0 degrees, which is to the right. 1 is 90 times 1, which is going to be 90 degrees, which is up. 2 is 90 times 2, 180, left. 3 is 90 times 3, which is 270, which is down. So we're going to just use these numbers in our step event and interpret movement. Okay. And we're going to initialize some variables that every step we can interpret and modify based on movement. So mx is going to be our shorthand for, or we'll say, movement input x. I got to try to break some variable naming habits so that when people pull this repo down, they can make sense of it. So movement input x is going to be 0. Movement input y is also going to be 0. Okay, and keyboard inputs I. So if we're holding this keyboard key that we've stored in this array slot, then we can go ahead and figure out, okay, well, what direction are we trying to move here? And then we'll just say movement input x plus equals length dir x. Best function in GameMaker is the length dir. length to x, we're going to just go 1, and direction is this movement direction. Same thing with y. So this is going to modify our x and y inputs. Okay. Final movement, or else just say if abs input x or so if the net result of this is that at least one of these is not equal to 0, then we've passed in some movement inputs. So at that point, we can move the player. Let's initialize how fast we want the player to move. Move speed base equals, let's just go with 400. I don't know. That seems fine. Okay, so we're going to be moving around. We got our movement inputs. So first, let's get our direction here. There's one thing that this will end up with is if we don't, so now we have to kind of normalize this. So we'll say like what direction is the sum total of our movement inputs, and then we'll move at our normal speed in that direction. So we'll say equals point direction, 0, 0, movement input x, movement input y, and now all we have to do is just move in that direction at that speed. So this frame movement equals move speed base, or oops, move speed base times 1 over room speed. So probably one of the next things I'm going to do is fix this room speed thing, because this is frame dependent. One sec. Got a sneeze coming, I can feel it. All right. So we're just going to move, let's update this, movement pixels. All right, so in theory, as we input our keyboard inputs, this is going to grab all of our inputs, convert them into a direction, and we'll just move in that direction. So you notice that this does also solve that problem of, in a lot of games, if you just like add the X movement and the Y movement together, then you'll end up with the character moving diagonal faster than how they move in other directions. So we don't have this problem here because we're grabbing the direction first and then we are moving using length to X. So this is pretty smooth. We also have this problem of, hey, I'm not looking left and right when I move around, and I'm also, this character's kind of boring, it's just sliding, which is no good. So we will fix those problems. So every world element should have an X scale. Oops. Also, I never change the image X scale and image Y scale unless I have good reason, because that also changes the shape of the collision mask. So instead, I'll tend to make my own. So I'll just say X scale. X scale is 1. And now we just say if movement input X is greater than 0, X scale is 1. And if input X is less than 0, X scale is -1. An alternative way to do this is to say if movement input X is not 0, then X scale is sine. So this is a cleaner way to do this. So the sine is just positive or negative, +1, -1. So now we just say, hey, if we're moving left, our X scale is -1. If we're moving right, X scale is +1. And then in the draw event of the player, our X scale is just going to be X scale. So now it should be as we press left, right, walk around. So we're all good. So you notice that as we walk up, the character doesn't look away from the camera. That's fine. Nobody cares about that. If you played our game Crashlands, you'll notice that none of the characters ever look away. They only ever look down right or down left. And as long as their movement kind of generally matches that, people are more focused on the left-right flipping. So this is totally fine. All right, I'm going to push this. Player character can now be steered with WASD. You guys have any questions about what's happening so far? Hope I'm not blazing too fast. Okay, so before we go, do I think sprites should blink to improve the game? Yeah. Yeah. Any small thing you can do to make things feel more alive in your game, you absolutely have to do it. If you have completely static anything, I mean, you notice how like I spent the first 20 minutes making my main menu screen wave around and do stuff. You just want things to feel good. You know, things should feel alive and not feel static. And so everything that you can do to do that, you should. So probably by the end of the stream, I also hope to have the player bouncing around and squishing. Because what I want to show is that even with bad art, like this little cube guy, you can still make a game that feels really good to interact with. And that's kind of half the battle there. Whoop, that's not what I need. Add group, there we go. Time, we need some time functions. Init time. Do I ever critique other indie devs' games? Yeah, sure, I do that sometimes. A lot of times, though, when people hand their games over for critique, they really just, they want affirmation, so it doesn't always pan out. Because whenever I hand something to somebody, the only thing I want to know is what needs to be improved about it, just because of the fact that if somebody only gives me positive comments, sure, it feels good, but now I have no action items. Like, I can't do anything with that other than walk home and feel good, right? So we're going to make some time variables. So we're going to say game speed is 0. Actually, we'll just do this. So in all of our games, we have this variable called SPD, which is a global game speed controller. So we should be able to change this variable, and everything in the game will respond to this. So we'll show how to do that. Yeah, I think the other issue with people looking for feedback is if you hand somebody your game and ask for feedback, you have to be pretty specific about what kind of feedback you want. Because, of course, if your game is nearly done and you hand it to somebody and they're like, honestly, this whole concept I just don't like, then like, well, what are you going to do? What are you going to do with that? You know, you can't just redo the entire game. So it actually goes on both sides of the feedback, where you need to be very specific about the kinds of things that you're looking to improve or change, and then get feedback about those specific things. Okay. Seconds since update. So I'm going to basically put together some time-based functions. That take into account the global game speed. Seconds since update, slow milliseconds. init time. Time update. So every frame, we're going to update our time variables. Okay, so seconds since update and slow-mo seconds. It's going to be this. Oops, not. So delta time is the number of microseconds that have passed since the most recent frame. So we're just going to take delta time divided by 1,000,000. That's how many seconds have passed since the last frame. There we go. Oh, get out of here. Get out of here, you. There we go. Yeah, there's actually a book called Thanks for the Feedback, which is about all of this, which is people are both bad at asking for feedback and bad at giving feedback. So it's kind of a tough line to walk. All right, so we have slow-mo seconds is speed times seconds since update. So this means that if we ever change this speed variable, let's say to like 0.1, then our seconds since update will just automatically be throttled down. Okay, so we have time update, and the time update function needs to be called always. So, for example, in our main menu object, we can now bring this in and we can say, in our begin step, the main menu will update the time. And in the draw event, or draw GUI, instead of this whole like get timer, blah, 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 well, actually, I guess, yeah. Let's build this in as well. Let's see, time. Okay, and time update. I don't know about you guys, but I rarely think about things in millionths of the second. So being able to just get stuff in terms of seconds is much nicer. Boom. Look at that. Game seconds, game seconds. Okay, and then in our gameplay object, we are going to begin step. We're also going to do time update. And now we're going to Control-Shift-F, look for room speed. Anywhere we use room speed, we need to not do that. So now we say move speed base times slow-mo seconds, which is, now we can use slow motion. So we could have used, seconds since update, but that's a static value that's just based on the frames, and we don't want that. Because you always want to open up the option for bullet time. Then blink. Presumably blinking should also use... let's see. Yeah. 2 over room speed. Okay. So just for safety, let's check and see if this is all working. Oh, I can't move. And I think it's because I defaulted speed to 0. So, whoops. Okay, so everything is still working. We just replaced all that frame-based stuff with time-based stuff. So we're not using delta time. All right, so I will push this. So you notice I'm doing pretty frequent commits. Anytime I successfully finish a change and test it, then push that out. Converted frame-based code to time-based. Next up, we want the player character to bounce. So in our world element, remember we have this z and this z speed. So let's use those. So for starters, we want the character to be drawn at, we want to take their z into account. So as z goes up, then the character goes up. But since in GameMaker, the y drawing on the screen is negative goes up, then we're just going to subtract z. So it's a little bit of a weird conversion issue, but we'll just take that into account. Okay. So for starters, we can just do something maybe simple, which is we can just say to the character, if z is less than or equal to 0, then that means we're on the ground. So we're going to say if z is less than or equal to 0, z speed equals, say, 200. I don't know. Because the problem here is we don't actually know what our gravity is yet. So let's actually do that. Gravity is going to be, I don't know, 4,000 pixels per second. Z speed of 500. So I'm just kind of playing around with these numbers, and they're easy to adjust, so we don't really have to worry about it that much. And let's also, in our time update, so this is how much, instead of every time we want to move something by gravity doing this, we can also include this gravity, this frame. So gravity of this frame, also 0. So if we're on the ground, then we set our z speed to 500. If we're above the ground, then we'll go ahead and modify our z speed by gravity. Let's see, z speed plus equals gravity gets frame. Gonna add. Minus. Actually, you know what? Let's do this. Let's treat negative z speed as up so that it matches how y works. Do this. Okay. I think that's right. Might be having a brain meltdown. All right. Z plus equals z speed times slow-mo seconds. Z speed plus gravity per frame. And then we should always cap your z so that you don't fall down through the ground. So I guess it'd be min, actually. And if z greater. Okay. So I think this is right. So all this should do is make the characters bounce up and down. How do you prevent collision problems caused by delta time? Yeah, that's a tough one. So in a lot of cases, like in Levelhead, we do have some of those with the GameMaker specific collisions. We have a lot of collisions that are our own, where we essentially, if a thing is moving too far, that it would start to skip like grid spaces or something, then we actually break that down into multiple chunks of movement and act under the hood. We act as though it is moving little bits at a time and check collisions at each point. Yeah, we want max. So your z speed goes negative 500. Z speed plus equals. Let's see. So z negative, z goes up. So then add gravity. If z is should be min, right? What are we doing here? Gravity of this frame. Yeah, we want min because z goes negative, which means if it goes greater than 0, it'll stop at 0. Plus equals z speed times milliseconds. But this is definitely not doing what we need. So let's do some debugging. Like this. X, Y, string, Z speed. Scale 1, C red. So my Z speed is negative 1,000, but it's not doing anything else because of this dumbness. Know what I mean? Okay, so this is with a Z speed of negative 1,000 and gravity of 4,000. So you notice that, like I said, the shadow is the actual location of the player. And then what we're doing with the character sprite is just drawing it at different locations to simulate vertical movement. Okay, so we probably don't need to draw that debug code anymore, because now we know what's happening. Now we can kind of play with the values a little bit and get a bounce that feels better. Okay, so this is... So the crazy thing about dealing with gravity is that you notice that I cut the Z speed in half from the bounce, and I'm jumping like a fifth as high. So you got to really be careful when dealing with speeds and gravity, because it feels like either nothing is happening or way too much is happening. So you got to kind of ride that line. And then interestingly, we can even in the gameplay controller, just to kind of show you guys how the time stuff works. I could say, like, maybe at the end step, so I could just have this toggle game speed and go into half speed or full speed, just so you guys can kind of see that this is all. So if I hit spacebar, then now I am in slow motion. So we already have a system in the game where we can do bullet time kinds of things, which is really useful for if you ever play fighting games and stuff. You'll notice that like when a big impact happens, there's like a flash of slow motion. So we can do that kind of stuff in this game as well. It makes things feel a lot more impactful. Okay, so we have our gravity here. All right, next up we're going to so we have this. We're going to keep the Z movement here because that's just a permanent thing that the character does. And we can even let's see, script. Gameplay. So this is probably something that we're going to be doing in a lot of characters and stuff. So we'll just make an update Z script that takes care of that on its own. And we are also going to say here we're going to now only, if we are giving movement inputs and our z is greater than or equal to 0, only then will we we modify these. So that means we're only going to start bouncing when we walk. Okay. So now we got something a little bit more lively, a little bit more responsive. But it's not enough. We need more. So a lot of times people will talk about doing a polish pass on their game, where basically they will build the game, and then at the end they will polish it all up. I like to do a lot of the polish stuff kind of midstream, because I think it actually does. It's not unimportant. It does a lot of work to influence how the game feels. So if you can have things blink or be squishy or whatever, even if the game isn't that mechanically interesting yet, as long as it feels good to interact with, then you're already in a really good spot. So we're going to now work on. So you notice I'm kind of separating these things out in convenience functions and gameplay functions. Convenience functions I basically think of as things that are not specific to this game, which maybe this update Z, maybe that's not specific to this game either. But things that basically could be just used pretty much anywhere in any game, and that it would still be fine. So that you could essentially package up these convenience functions and bring them with you wherever you need them. Hey, delicious cookie. What's this game about? I don't know. That's up to you. I'm just making stuff for fun and talking about what I'm doing. So, all right. So this player, we're going to need things to squish, I feel like. So let's start with some squishing. All right, so squishing is simple. Squishing is essentially whenever you shrink something on the X scale, you expand it on the Y scale. If you shrink it on the Y scale, you expand it on the X. So it kind of feels like when you push in on it, then it kind of, squishes. So we're going to just make some squish functions so that the player can feel a little bit more, squishy. And this is what we used in fields of goop and all over the place. This is also used a lot in level head. Like you notice when GR18 is bouncing around and jumping, we have a lot of squishes happening. And that was actually in there the first day that we started working on level head. Was we had like a square running around, but it was a very squishy square, so it felt really good. All right, so squish. So squish set. So let's see. So I need squish, and we will say squish amount. So all we're going to do is equals ANT. And this is just going to basically say if you squish in the positive direction, then we will expand the X and shrink the Y. And if you squish in the negative direction, we'll just do the opposite. So X scale equals 1 plus amount. And then last, we'll have squish update, which will just go squish X scale. So let's do this same thing. So you kind of see how this works in a second. Squish amount. So we're going to, every frame, we can then update how much something has squished on its X and Y. And then we can change the squish amount by using a lerp function. So lerp is short for linear interpolation. Let's see, squish amount 0. So linear interpolation in this scenario basically just says every frame we're going to close 25% of the gap between this first thing and the second thing. So if our squish amount is 1, then we're going to end up at 0.75 at the end of this frame. And then once we're at 0.75, then we're going to go whatever 2/3 of 0.75 is, blah, blah, blah. So it kind of creates this like, it moves fast at the beginning and then slows down toward the end. So we're going to lerp our squish amount towards 0 after we update our X scale and Y scale. So let's use this. And just for naming, let's start all the squish functions with squish. All right, let's see. So in the step event, we're going, when we do our bounce, we're also going to squish. So we'll just squish by like 0.2, and we'll see. Actually, let's make it really intense just so we can really see it. So it's kind of a good way to debug your stuff is go extreme with effects at the beginning and then ease them back after you establish that they're doing what they need to do. All right, so now I need to update my X scale and Y scale. So first we're going to say squish update in the draw event. So remember, the squish update will modify X and Y squish scales by the amount that we have squished, and then it's going to, after it's done that, work the squish amount back toward no squish. So since we've run squish update, then we should be able to use the squish X scale and the Y scale. So this isn't quite going to work as we want just yet, so there's a little bit left to do, but I'll show you what this looks like at the moment. Assuming we did everything. Squish set, squish init. Okay, so that's a squishy squishy dude there. Or lady. It's kind of hard to tell at this phase. Okay, so what you'll notice about the squish, and I'll actually do this just so you can see it a little bit better. I'll just set the squish every frame. So notice I am floating above my shadow. And that's because the player's origin is here in the center. And so when we squish vertically, then it's going to squish down from the top and up from the bottom, which means my feet are going to come off the ground. So that means, yet again, we need to modify our Y draw position. So right now we're subtracting our height. We need to actually subtract our height times how much we're being squished, because our height is actually shrinking visually. So so now you notice that I'm now right there in the middle of my shadow, so that's good. And now I can stop squishing every frame so we can see if this is doing what we need. All right, so this is like way too squishy. And maybe it's squishing the wrong direction. As I'm jumping, I'm kind of flattening, but maybe not. So we'll just do a couple experiments here. So first, let's reduce that by half, so 0.25 squish. We just want it to feel like the character's kind of like got something going on. Okay, and then let's try a negative squish. No. This is better. Okay. So we will do 0.2 squish. That should do it. All right. I'm going to push this. Player character squishes. And for those of you who are new to the stream, I do have all this code available for download in a public Git repository. So the link is just down below. So if you just want this code, if you just want to have it, then you can just have it and do whatever you want with it. All right, so we've got about 20 more minutes, so we can still do quite a bit more with this character. So let's do that. So let's update so this world element. We're going to give this, we're probably going to end up squishing and blinking a lot of things. So let's just move the blink and the squish code into this world element parent. And we're going to probably also have a rotation. So let's do that as well. Okay, so we are going to draw the player by rotation. And we want the player to kind of like bounce around or kind of rotate as the character bounces. So for starters, let's just say rotation is, I don't know, 45 degrees. So we can draw the player by rotation, and then we're going to, once again, use our leg function. So this is going to mean that every time the player bounces up off the ground, it's going to kind of kick backwards, which is kind of odd, right? Doesn't quite feel right. So for starters, let's actually knock this squish down again. Okay. So we have that. Let's also bring this variable. I always just call this leg position. Can be whatever you want. All we do is we just invert the leg position with each bounce, and we change the rotation by that. And we could probably go quite a bit less rotation. So see that? So every time we initiate a bounce, we invert the leg position. So this should cause the character to bounce in different directions as you walk around. And let's actually slow down that rotation change quite a bit. All right, so we've got some, ooh, and actually let's say, if Z, if you're on the ground, then let's really resolve that rotation. But if you're in the air, we can maybe slow that down a little bit. All right, so we got this little cuboid person. Feeling pretty good about this. Okay. So let's push that, and then let's put some stuff in the world. Let's spawn some things in the world so that we can get a camera and maybe have the camera follow the character around. So King Java wants to know about how to do slow motion replays. So my thinking on that is basically those are two separate problems. So one is you just need some kind of replay recording system where basically you are recording positions, animations, stuff like that of all the things that are happening in the game. And that's one layer of it. The other issue is the slow motion part. So if you're recording timestamps with all of your replay stuff, then it should be pretty easy to just modify those timestamps, or sorry, modify your time as you're running through the replay by some sliding scale, so that basically just events happen at different points. So Okay, so I've got this blue thing. I just need something in the world that I can use to give myself a frame of reference. So we'll trim that down. It's just kind of a blue thing. I'm going to make a berry. There's an object. Its parent is also going to be world element. And we're going to do the same thing we did in the player, but a little simpler. Oops, world background. That's the wrong thing. World element. Okay, so we're going to draw our shadow. We are going to draw our sprite. This thing doesn't blink, so we're not going to worry about that. We will still take its height into account, and it's Z. So what we have here is some dry violations. Dry meaning don't repeat yourself. So this code is just taken straight from the player character and duplicated. So whenever you find yourself doing this, you want to try to come up with a mechanism where you aren't doing that, and that's where creating scripts comes into account. But sometimes you have to repeat yourself a couple times before you find the patterns that you need in order to go back and fix those issues. All right, so we have our berry, we have our shadow. Let's make sure we get the height and the width of this berry correct. So it's 54 and 54. I'm just coding these widths and heights up by hand for now, and then presumably later we may have some better way of handling that. Okay, so we're just drawing this berry, etc., etc. So the reason I'm doing this is because if we want the camera to follow the player, we actually won't know if it's really working. Am I hitting save? Yeah, I'm hitting save every time. I save like every time I finish a line of code. And in Game Maker 2, saving is super fast, so it's nothing. Okay, so gameplay controller. First thing we're gonna do is we're gonna spawn a bunch of berries. Now berries, we're just about like 300 berries. Spawn range, let's spawn him in like a 2000 range. All right, so these are just going to exist to give me a frame of reference. These are not actually interactable mechanical items yet. Okay, so a couple things here you may notice. There's no depth sorting going on. So when I walk on these, my shadow's on top of them. I'm on top of them. None of this makes any sense. Their shadows are too big. There's just a lot of dumb and bad stuff going on here that we're going to have to fix. So first, we're going to make a script that manages depth. So we'll just say update world depth. And all we're going to do for now is just depth is -y. That's it. So in the berry, these are not moving objects, so we can just do this in the create event. And in the player, we are moving around all the time. So we're going to update our depth at the end of all of our movement code. And we're just going to do that all the time. We could maybe just do it whenever we move, I suppose. But it's possible that later other things will move us. So it's probably good to just do it every frame and not worry about it. And actually in world element, let's just do this baseline so that we don't have to worry about doing it in the create event of every single object. So you notice how useful it is to have everything in the world inheriting from this one object, because as the game gets bigger, we're going to have a lot more shared functions. Okay, so we now have our depth being updated. Let's... Okay, so as you notice that as I get in front of it, then we now have this thing going on. There's no collision happening, so I can just walk right through these things. And they're big enough that that feels weird, right? So if they were laying on the ground or whatever, then I should be able to just walk right over them. But these are big enough that I should probably actually be colliding with these. So we'll have to deal with that. All right, King Javo, thanks for coming by. I should be streaming actually tomorrow morning as well. So I'll be putting another couple hours into this. Okay, so we're walking around this field of berries. Also, these berries are all the same, which I don't really like. So let's solve that first. Scale modifier 1. Berry. Random range. And so we're just going to apply a scale modifier to these so that we have a little bit more variety in the world. And we can also randomly x-flip them. So now we got a little bit more of an interesting thing going on here. But still the shadows are not good. Especially, yeah, you can see that like shadows, we'll actually see how the shadows sitting on top of my character. So the shadows is actually something that we should fix sooner rather than later. I'm going to push this because now we have some stuff in the world, and then we'll go from there. I think I can do it in 5 minutes. This commit is just that there are berries, so. Okay, so we're going to make a new object called shadow draw. This thing draws the shadows. So it's going to check with each world element. If shadow draw, so this is just a Boolean. And then we're going to make a script. Draw shadow. This is to be called by any world element. We're going to draw sprite, sp shadow, at 0, x, at an x and y position. Shadow scale. It's going to be width, let's see, divided by. So we're going to scale the sprite by the width of the object. So that as we get smaller and larger objects, the shadow scales up and down on its own. No rotation, and 0.25 alpha. Okay, so we'll try this. So the shadow actually should give us then a sort of an indication of how large or small an object is as well. And in the player, I'm going to stop drawing shadows. And in the berry, I'm also going to stop drawing shadows. So now we've gotten rid of some duplicate code here. In the gameplay controller, aside from the world background, we can now make the shadow draw object. So we're going to have some depth problems with this, which we'll solve in just a second. But first thing is just getting it up and running. Okay. Nice, nice. And I believe where we're at is, I believe the top left corner is 0. So if we were to go up a little bit higher, then the shadows would actually draw on top of us. So we could just to show this, just say the depth of the shadow draw object is, I don't know, negative 500. So it's now we're drawing shadows on top of things. So what we're going to want to do is change the depth of this shadow draw object, the same as everything else. So we have this update world depth, which is depth equals negative y. We're going to move the shadow draw object with the camera. We're going to update world depth then, and then we're also going to add some amount to the depth so that it goes behind everything. So this doesn't exist yet, so we can go ahead and fix that. So let's just say shadows are, I don't know, 10,000 depth further back than anything on the screen. And let's do the same thing with the background. So the background should be back even farther than that. So world background. Y equals YU. So in both cases, the shadow drawer and the world background drawer will move with the camera, set their depth, and then update their depth based on some modifier so that they go further back than everything else. So this should mean now that no matter where we go, shadows and the background are always going to be drawn behind everything else. So it should be good. Okay, so that's a pretty good start, I think. We've got a little world to run around in. Nothing's really happening yet, but we've got kind of a little juicy game going on. So I think next stream, which I'm going to be doing tomorrow, 10 a.m. Central Time, I'll put up an event. So next time we'll be working on probably like movement collision as we walk around, and we'll also be working on a camera so that we can follow the character around, and then kind of depending on where we're at from there, we can even look at dynamic spawning of world items as you walk around. So we'll just kind of see how far we go, and if there's anything anybody else wants to see tomorrow, then if you're in the stream, just go ahead and drop stuff in chat. And I have no preference on where this game goes or what we end up putting in this game. I was kind of hoping that people in the chat could sort of throw their ideas in, and we could just kind of see where things go. So, because really this is for you guys. So, whatever you want to do, we'll do it. All right, you guys. Well, thank you very much for watching, and I'll see you tomorrow. Adios.